Yes, sir. We can already.
Can, okay.
Yeah.
Okay, so all right. So everybody can see, right?
Yes, sir.
Yeah.
Interpolation, definition, the process of feeding a function to given data. For example, so you have an axis, let's say, for example, you have some data points. If anybody is playing music, please try to stop it. I can hear music coming. G, are you playing music? So this is the given data. So this is the given data. Okay. So we try to find an equation for data. And this is the equation. So some of you, I think you guys might want to off the mic. There's a lot of noise coming here. You want to turn on the mic only when you want to ask questions. Hello? Can you guys hear me?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, so we fitting the given data. The data is given in red, and then you want to fit that with a function called px. That is called interpolation. The most usual class the most so it's very common to use polynomials. You guys probably know what is polynomial from your college algebra class. It's just a function that's always continuous. The process of feeding through a given data is called the process. Since there's some latency, I'm going to write first and then I talk. In that way, it will match. The process of feeding a polynomial through given data is called polynomial interpolation. Okay, can you guys hear me clearly?
Yes, sir.
Yes, sir.
Yes, sir. We can.
So screen all okay, right?
Yeah, okay, sir.
Okay, just bear with me for a while. We'll try to finish this as soon as possible. Actually, this mathematics, engineering mathematics 2B is numerical analysis. This class can get very difficult, you know, so I'm trying to make it as simple as possible so that everybody can follow. Okay, now let me introduce to you what is Lagrange interpolating polynomial. Lagrange example. What's a Lagrange interpolating polynomial? Let's see what it is through this example. Example, Lagrange interpolation polynomial. Given values of fx at n+1 distinct points. For example, if I given values xi, I can be 1, x1, x2, x3, x4, and xn, x of n. And then the corresponding fxi values will be x1, or you can just call this f1, the same thing, fx2, so given values of fx at n+1 distinct points, given values of x, given values of, actually supposed to be given values of fx at n+1 distinct points. Don't worry about that. If you are really confused, if you're slightly confused right now, don't worry about this. When you do an example, things will become very clear. For this is just telling you, you are given some points, x1, for example, it just telling you, you're given some points. This is like fxi, and then this is xi. You just given some points. That's all it's telling you. Okay. Given these points, find a polynomial of degree n. A polynomial degree n, you can call it px, p as a function of x, such that Find a polynomial of degree n, px, such that pxi is equals to fi, where I is equals to 1, 2, 3, and so forth. What is it telling you is you should be able to find the polynomial. This is the xi, right? And fi. So maybe let me put this in a different color. What the statement is telling you, let's say you have a data point here, xi, fi. You should be able to match with the polynomial. Let's say the polynomial is passing through. Let's say the polynomial is passing through. And then it should match with the value you should have a polynomial that perfectly matches with the data. That's all it's telling. Okay, guys, are you all following?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Can I proceed? Got any questions? Did you all have
No,
breakfast?
Yes, sir.
Yes, sir.
You had breakfast, right? You can have breakfast while watching this, you know. Nobody's going to say no. You can drink coffee, tea. Don't drink anything else.
Okay, sir.
A polynomial of degree n has n plus 1 coefficients. Okay, this is, let's say, a piece of x is the polynomial. Usually polynomial have a constant, and then you will have the degree of polynomial, which is called n, and then plus all the other terms, you know, a1 x plus a naught. Polynomial, this is the degree of polynomial. The polynomial, for example, just give you a numerical value. If n is equals to 3, example, if n example, when n equals to 3, you're going to get a polynomial, say p4x. The 4 stands for, this 4 here denotes there are going to be 4 coefficients. 4 coefficients. And this is the degree. For a polynomial of degree 3, you will have 4 coefficients. I'm just making this polynomial up. There's no, I'm just making a polynomial here. For example, there's no significance in this. Just an example. Okay, polynomial of degree 3 will have, a polynomial of degree 3 will have 4 coefficients. There's one coefficient here. Is hidden is 1. There's another coefficient here. There's another coefficient there. 2, there's another coefficient there. So you can see there are 4 coefficients. 4 coefficients. Okay. So for n data points, okay, therefore there's a n plus 1 coefficients. N plus 1 is 4. Okay, the degree, this is the n is the degree. The degree plus 1 gives you the number of coefficients. These are very basic. These are just basic steps that I'm just doing a quick review. I just not really so important, but just to make sure you understand what's a polynomial is, how the degree of polynomial relates to the coefficients. Okay, if you have 4 coefficients, then the degree must be 3. Sometimes you might have 0 coefficients. Let's say for x squared, if you have 0, then x squared may not appear there. And therefore, n is the order of the polynomial. N plus 1 is the number of coefficients. Let's do a quick example now. This is only example. This is just a quick example to show you how to derive a Lagrange polynomial. The simplest case, given 2 points, find a polynomial find a polynomial of degree 1. So this is the number of points given is n plus 1. But your polynomial is going to be just n. Degree of the polynomial is going to be n. So if you have n plus 1 points, the polynomial that you're going to end up will have will have a degree of n with the n plus 1 coefficients. Find a polynomial of degree 1. Of course, for only there's only given 2 points is given. There are only 2 points given. The polynomial that you're going to find will have only a degree of 1. Find a polynomial of degree 1 such that okay, guys, can you all see everything clearly?
Yes, sir.
Can you hear me? Nivedya?
Yes, sir.
Yes, sir.
Okay. Okay, let me plot these points. Let me plot these points. At x1, you have f1. So this is one coordinate. At x2, you have f2. So this is the other coordinates. These are the given points. These are the given points. Okay, so these are the given points, and that's in red, the given point. Given points as one here, and then there's another one over there. Okay, so we're going to try to find the polynomial equation of the polynomial for this data set. Since this is a polynomial of degree 1, since this is a polynomial of degree 1, so it's going to be a straight line, right? Right or not? Y is equals to x. It's just a straight line, isn't it? For example, it's a degree 1, for example. So Px is the polynomial. Now, in order to, we're going to find out the equation for Px. Since this is a straight line, you know how to find the equation of a straight line. In order to find the equation of the straight line, you need the slope. One of the things that you need is the slope of the line. Let's call this M. The slope of the line, you just rise divided by run. Rise means like y, just well, this is called rise. Not the rice that you eat, this is rice. This is the run. That will give you the slope. Okay. So next we find the equation of the line. Equation of the line. So do you still remember how to write the equation of a straight line? Okay. This is the equation of the straight line. Any question?
No.
Am I doing it right, JJ? G?
Yes, sir.
JJ and G. Quite, JJ?
For the m equal to bracket x minus s1, am I right? Not x2 minus s1. Is it?
X, which one?
M bracket x minus s1 bracket, am I right? Not x2 minus s1. For the
Oh, yeah,
equation
right.
of the line. Yes, sir.
Yeah, you're right. I mean, in this case, we are looking at a set of points. We are looking at, you're right, you know, that is supposed to be just x. Thank you. This is supposed to be just x. Okay, guys, what we are doing, we just writing the equation for one set of points. Okay, this is one set of points. We take this set of points and then we are writing y minus f1 is equals to slope multiplied by x minus x1. Thank you very much, JJ. Because this video is going online in YouTube, the whole world is going to see our mistakes. So please help me out, guys. Even if there's a mistake, is okay. In the next video, I can say sorry. Not a big deal, right? G, hello, G. Can you guys hear me?
Yes, sir.
Yeah, sir. Yeah.
Can, sir.
Yeah.
I
Yes.
keep making some noise so that I know you guys are around, because sometimes this Zoom go offline. So I'm trying to do it as soon as possible. Sometimes you go offline and then it comes online again. So if you are missing the screen or anything, please screen. Okay, then we replace the m with the, we go ahead and substitute m with its slope equation. Next, what we do, we just play with the algebra and bring it to a standard form. Bring this f1 to the other side, it becomes plus f1. Okay. And next, what I'm going to do is I'm going to factor out the f1. Just going to pull out this. Right, it's two equal sign here. Okay, I'm going to pull out the f1. Pull out the f1. Factor out the f1. So what do we have inside the parentheses here? We have, after you factor out the f1, what do we have here? 1 minus x2 minus x1 divided by x2, sorry, x minus x1 divided by x2 minus x1. Plus we're going to have f2. There's some mistakes in my notes. I didn't. Okay, on this side we will have f2, right? f2 So on this side, we have x2 minus x1. Okay. Is the algebra looks okay? G, if you are coughing, you're supposed to use an handkerchief.
All right, sir.
So cross multiply x2 minus x1. G, are you making that noise?
No, sir. No, sir. I didn't make a night.
Okay. Okay, please turn off the mic, unless you want to talk, because it's creating noise and all the other participants will hear the noise and they might not be able to catch what I'm trying to say. Okay, we cross multiply and then we cancel this, one of these cancels, and then we end up with this equation. We are not done yet, just very close to being done. So we're going to just multiply top and bottom by a negative sign. Will give you x2 minus 1 minus x becomes x minus x2 divided by just a rearrangement, and divide by x1 minus x2. Just multiplying by a minus sign top and bottom. Can I do that? No problem, right? The next one, there's no change. Just repeat. Okay.
So
Yes.
for the behind part is F2, right?
F2. Oh yeah.
F, yeah.
Oh yeah. Thank you very much. Thank you very much. It's supposed to be F2. Earlier on, I changed the subscript and I forgot to change them. Because earlier on I had F1 here and I wanted to change the subscript because the following example using F1 and F2, earlier on it was F0 and F1. So I changed the subscripts and I forgot to change them. Now, thank you very much for this. Okay. Now, is it okay now?
Yes, sir. Everything is okay, sir.
Okay, thank you. So this okay. The box, the pink box related to F1 is called L1X. The pink box related to F2 is called L2X. Okay, these are, okay, there's some differences from my notes. Yeah, I'm trying to, in my notes, there are too much details. Student can go confusing. In classroom notes, it's a little bit too long. In this video, I try to remove some unnecessary stuff. But see, still you can read the notes. The video, I made them a little bit compact, to the point, because we are online. The video becomes too large, I have problem uploading. The uploading is so slow. If it's at the university, it's fine, it will upload very fast. This is called, G, did you read the notes? What is this called? Anyway, are you guys reading the notes? This is called the Lagrange. Lagrange polynomial.
Sir?
Yeah?
Yeah, for the F1, right, it's supposed to x2 minus x, right, over x2 minus x1.
For which
For
one?
the L,
F2.
for L1x.
Supposed to be x minus x2
x2
divided by
x2 minus x1.
for the F1. For the F2.
F1, sir.
There's some echo coming. Somebody, okay, because of this mic, I think. It's okay. So you're the one related to F2, is it?
F1, sir.
F1 on the
think,
left.
on the left hand side, sir.
This one.
Supposed to left. Yeah, this sir.
This supposed to be
x2. Because your circle one is different with the below one. You'll find the answer.
Oh, you're right, lah. Because what happened is I multiply by a negative sign, top and bottom. You know what I did here?
I don't get it, sir.
Multiply by negative sign, and then you also multiply by negative sign, top and bottom. So minus x becomes x. If you multiply this negative sign through, you will end up getting x minus x2, right? Then here becomes x1 minus x2.
Oh, okay, sir. Got it.
The reason we want to do this because we want to keep, I don't know, just for consistency. It's not really that important because we want to be consistent. If you keep this in a correct format, later on when you do the subsequent problems, things will be easier for you. It's not so important, I think, but we just want to keep that consistent. X minus something on both sides.
Okay, sir.
Yeah, okay, good observation, good question. Everyone should ask question. Once you clear your question right now, here and now, you clear your doubt here and now. You go home and you have nothing to study. Understand each one of you?
Yes, sir.
If you clear your doubt right now, you go home, you just study for 10-15 minutes is sufficient. Otherwise, you know what the lecturer did, I didn't understand. You'll go and ask your friend. Your friend said, I don't know, I was dreaming. You go and try to crack your head. Going to take several hours. That's going to disturb your sleep. That's going to disturb other things in your mind. So try to clear your doubt now. Even a small thing you must ask. I'm not going to scold you. Gee, I never scolded you, right? G? Hello? Can you guys hear me?
Can, sir.
Can, sir.
Can, sir.
G?
Yes, sir.
Okay. Maybe G turned off the mic. I think it's okay. When you guys turn on the mic, there's some echo is coming, like a screeching sound. But that's fine. When you have to ask question, you have to turn on your mic. Do anybody want a break, or can I continue? Just a short only. Can I continue?
Yes.
Yes, sir. You can continue.
Can, sir.
So therefore, we found out that L1x So your L1x, which is called a Lagrange polynomial, L2x is also a Lagrange polynomial. These are the things that is required to form a Lagrange polynomial. Somebody is having the mic turned on and there's noise coming out. If you have no question, please turn off the mic. Thank you. So now you know we have a Lagrange polynomial. We try to evaluate this polynomial at those two given points. Okay, we start. At x equals to x2, we evaluate L1. We substitute the x with x1, x2, and then we evaluate the L1, and then we result in 0, right or not? Because these two is cancel. 0. 0 divided by anything is 0. L2x, again now you substitute x with x2 in L2. That's going to give you x2 minus x1 divided by x2 minus x1. What's that going to give you, G? It's going to be 1. Next, you do the same thing for the other part. You substitute your x with x1 and x2. And now you substitute L1 x1 and then L2 x2 as L2 x1. You substitute. If you do the similarly, if you just did what I did on the left hand side, you will end up getting 1 here, and then you will end up getting 0 here. Okay, it's a simple algebra. I'm sure you guys can do it. If you cannot do it, you can ask this question again next time. So So after evaluating those Lagrange polynomial, the overall
I do
polynomial.
apologize due to my Wi-Fi is unstable.
You cannot see?
I can see, sir, but I miss all the lessons that you have learned, sir. Because of Wi-Fi, it's unstable.
Okay, never mind. When I upload this video later, you can watch it in YouTube, and then you can ask questions the next time. Okay.
Okay, okay, sir.
I was going through very slow, and it's quite easy to follow. I hope you will catch it.
Okay, sir.
Okay.
Okay,
So we haven't done everything complicated yet.
okay, sir.
So Px is, so now we're going to substitute what we evaluated earlier into the polynomial function Px. When x equals to x1, what do you got? Well, you got Px1 is f1 0, 0, remember the 0? Right here, this 0, right? You just substitute whatever you got here into those equations. F1 multiplied by 0 plus F2, sorry, not 0, F1 multiplied by 1. F2 multiplied by 0. L1 x1, you know right from here, remember? L1 x1, it gives you 1 right here, L1 x1. L2 x1, L2 x1 is right here 0. Okay, I'm just substituting these values. So this is going to be 0. So you're going to end up with F1. When x equals to x2, Px2 is equals to F1 multiplies 0 plus F2 multiplied by 1. So this is going to be 0. That's going to be F2. All right. So now Px is the unique So Px is the unique linear polynomial passing through the points x1, f1, and x2, f2. Any questions so far? Anybody, any questions? Can you guys hear me?
Yes, sir. No question.
Okay, thank you.
A question.
Okay, so I will just have one more example, then after that we'll be done. Maybe another 15 minutes. In general, in general, a given endpoints. So now if we have more than, let's say we are given numerical value, how do we solve this? So this is the formula that I'm going to give you right now is going to help you to do that. In general, a given endpoints where k is equals to 1, where k is equals to 1 to n, the interpolating polynomial passing through the given points, etc. Piece of n xn is equals to yk, where k is equals to 1, 2, 3, n. In Lagrange form, okay guys, this is the formula for you to, if you are given a set of points, this is the formula that you need to create the polynomial, to find the polynomial, Lagrange polynomial equation. Quite a fun equation, right? So this part here is just telling you the sum. As you sum, as k is summed from k is equal to 1 to n. K is 1 to n, and this part here is the product. And this is the voice of k. This is the data point, one of the data point. So it's going, this equation is sum of product multiplied by voice of k. Now we will look at an example and see how this formula is applied. This is the only example I'm going to do, a very simple example. After this example, we'll be done. So please try to pay attention. Okay, are you all still there?
Yeah.
Yes, sir.
Yes, sir.
Okay. Example, you are given This is x and y. X points are 0, 1, 2, 3. X points are 0, 1, 2, 3, and y points are -5, -6, -1, and 16. Okay, let's call these points okay, let's call that x1, x2, x3, and x4. The number of data points n is equals to 4. Okay, now you see how to use that formula to do this problem. So I'm going to use this formula to create the Lagrange polynomial. First of all, you know that n is given as 4. N is equals to 4, right? N is equals to 4. That's the number of data points. Therefore, you replace the n with 4. Summation k. Summation is k is equals to 1 to 4. And then the product I goes from 1 to 4. The condition that I is not equals to k. Let me put this in red. This is danger. I cannot be k. When you see a term that is same, when I and k is equal, they'll get division by 0. You have to ignore that term. Okay, we will see how to do that. Okay, so now you see how to apply this formula. After you seeing this, you'll see, oh wow, so easy, you can tell. So what this formula is telling, okay, let me blow this formula up. So what this formula is telling, you fix k, okay, you fix k, and then run I from 1 to 4. Fix k and run I from 1 to 4. How many k values are there? 1, 2, 3, 4. So you have to do this 4 times. So you have to fix 4 times the k values, and each time you have to run the I from 1 to 4. Okay, guys, are you all with me?
Yes, sir.
Yes, sir.
Yes,
Okay.
yes, sir.
Yes,
In that
sir.
case, we can do the, okay, good. Let's do then. K, start with K is equal to 1 and run I from 1 to 4. Run I from 1 to 4. So that's going to tell me, okay, P4X. So we're going to do this 4 times. Let me write this first. So we're going to do this how many times? So you're going to do this like K1, K2, K3, and K4. Okay, the polynomial P4X is equals to, okay, let's do it for K is equals to 1. Let's do for this. K equals to 1 as I goes from 1 to 4. Okay, let's evaluate this. Okay, I'm going to substitute that. I'm going to substitute that in this formula here. I'm going to substitute in this formula. Okay. First, what is your K? K is 1. And then I also is 1. So X minus, let me change color. X minus Xi. Xi becomes X1 divided by X. K becomes 1. Okay, let me back up here. Okay, this is K. And this is I. This is I is equal to 1, K is equals to 1. Then you multiply by so you're going to multiply by the next term. This time, remember that you're going to fix K. K is still 1, but I is going to be 2. I is going to be 2, but K is still 1. And then multiply by, now next I is 3. So therefore it's going to be X minus X3. K is still 1. If you already fixed the K, right? X, so 1 minus X3. Then next I is equals to 4. K is still 1. Okay, then finally what you're going to do, you have, now you already K is still fixed at 1, so it's going to be Y1 here. K is going to be 1. Let me make this a little bit smaller, it's really big. Okay. So do you guys see how this is done? If you have problem again seeing, I can just, okay, this is K. This is I. You know, this is K. You know, this is I. This is K. This is I. This is I. This is K. This is I. Do you guys follow?
Yes, sir.
Okay. So once you follow this one, and then the rest is easy, you know. Let me delete all this. Otherwise, it will, once you understand this, the next is just copy paste, and then you just change the I values, that's all. And then the K also you have to change. The only change, okay, let me show you how to do this. Did I do something here? Okay, wait. Since you know I'm lazy, I'm going to copy and paste this. So I'm going to do this for K is equals to, like, let me write this. Okay, this is added. Let me, okay, I'm going to repeat now. K is equal to 2. So wherever there was K, you change it to 2. Right or not? K, wherever there was K, you change it to 2. Okay, here was, sorry. Wherever there was K, right, I change it to, because right now K is 2. K is 2. K is 2. Okay, do you see? The I, every time you change the K, and the I still sweeps from 1 to 4. Now K is 3. All I have to do is change the subscript to 3. K is 3. K is 3. K is 3. K is 3. Maybe there's not enough space, so I move it to the next page. I don't want to keep this too close, otherwise you guys have problem seeing it. It will become too small. For next case, K will be 4. Case 4. Now we change all the subscript 4. So you have done this. You have done this for K is equals to 1 to 4. Okay. You've done this K from 1 to 4. And each time when you change the K, you have swapped. Okay. So you sweep I from 1 to 4. Is this clear so far? Before I move on.
Yes, sir. Yeah, everything is clear.
Okay. So that's an important point. Okay,
Yes, sir.
good. Good. So that's an important point to note. Note that I cannot be K, right? Note this point, I cannot be K. I is not equals to K. So therefore, wherever I is K, you just ignore that solution. Just omit the term in the product. Can you see I is K here? I is equal to K. I is equals 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 to K. What are you going to get? You're going to get x3 minus x3. For example, x3 minus x3 or x4 minus x4 is going to give you 0. You're going to get division by 0. So therefore, this solution, this not the solution, this is part of the solution. This is a term that's multiplied with other terms. So when I is equal to K, you just drop it, drop the solution. No. Okay. So you guys can see, you just, it's already mentioned here, I is equal to K is not allowed. But I wrote that and to show you why is not allowed, because it's going to give you division by K. Sorry, division by 0. Do you guys follow so far?
Yes, sir.
Yeah, yes, sir.
We're almost done. Just plugging in some numbers. Just now you just plug in all these numbers that was on the table. The numbers was given on the table, right? So P4 now is equals to P4x is equals to x minus 1, x minus 2, x minus 3 divided by 0 minus 1, 0 minus 2, 1 minus 3, minus 6. Sorry, okay, this is just for information. Do you remember this value came from the table? This is x2, this is x3, this is x4, and this is y1. This is it's coming from here. It's coming from this part here. Okay. This is it. So you go ahead and do the same substitution for the others. Okay, go ahead and do the same substitution for the others. Let me delete this. Otherwise, it will look very messy. So can you go ahead and substitute for the rest of them? Do you understand this? How I got the numbers?
Yes, sir.
Yes, sir.
Everyone, okay.
Yes, sir.
Okay, the rest is just same thing, you know, you just plug in the numbers. So it's going to be x minus 0, and the next one is going to be x minus 2. Okay, I may have some algebra, it's possible for me to make some mistakes. So you just plug in these numbers, like this is the Lagrange polynomial. You can simplify this. You can just simplify. You don't have to really simplify too much. Just a little bit more. This is going to be 5 over 6. The first one is going to be 5 over 6, x minus 1 into x minus 2 into x minus 3. Okay, the next one is going to be plus x minus 2, x minus 3. Next one is going to be 1/2 x minus 1, x minus 3 plus 8 over 3 x minus 1. Something is missing here. don't know, x minus what is that? X minus 1, x minus 2. X minus 1, x minus 2, sorry, x minus 3. Why am I messing up a lot of things here? Okay, wait. X minus 1, x minus 2. But anyway, you know, this answer is not really important. The procedure, we can go and check and see if there is any mistake that you catch. Please let me know. X minus 1, x minus 2. Sorry. I forgot to. 8/3 x minus 1, x minus 2. Okay, guys, so this is called the Lagrange polynomial. This is called the Lagrange polynomial. Polynomial usually, you can multiply them and simplify them if you like, but I'm not going to ask you to do this in this course. If you multiply them and you can bring this in this format. This is in power form. To do this, this is in power form. To be able to convert that to power form, you need to do few hours of, I don't know, you need to spend a lot of time doing the algebra. You don't have to really do that. If you can leave things in this format, is sufficient. Okay. In polynomial, the procedure is important. Okay. So guys, I think that's all for today. If you have any questions, you don't have questions? Any
No,
questions?
No, sir.
Okay, sir.